Hey everyone! Today we're diving right in to decode some of the notoriously abstract concepts of advanced JavaScript. I know, these topics can feel like a total maze, and the friction points, yeah, they are very real. But as we explore these concepts together and actually practice what we uncover throughout this explainer, we're gonna walk away with a fundamentally new developer mindset. Let's take this abstract stuff and make it tangible. Here's our roadmap for today. Section 1, Scope and Execution Context. Section 2, The Power of Closures. Section 3, Building Toaster Notifications. And Section 4, Decoding the This keyword. Section 1, Scope and Execution Context. Visualizing the invisible. Understanding where variables actually live is often the first major hurdle for developers. So let's use a village analogy to understand lexical scope. Imagine you live in a specific village. Your village has plenty of wheat and stones, but it doesn't have a washing machine. If you want a washing machine, you literally have to travel to a different village that physically has one. Well, JavaScript works exactly the same way. The physical, literal location of where you write a variable in your code, the village it lives in basically, determines exactly where it can be accessed. To really lock this in, we've got to compare it to dynamic scope. In a dynamically scoped language, what matters is where a function is called from. But JavaScript, it doesn't care where you call a function from at all. JavaScript strictly follows lexical scope. It only cares about where the function is physically written in the text of your code. Your physical location dictates your access. Okay, building on that, how does the code actually run behind the scenes? As soon as JavaScript sees a function, it creates this hypothetical invisible box. This is what we call the execution context. And inside that box, two distinct phases happen. First up is the memory phase, where physical space is allocated for all of your variables. Then, right after that, comes the execution phase, where your code actually runs inside that very same box. I know exactly what you might be thinking right now. Where is this box? Can I see it? Actually, no, you can't. Execution context is highly abstract. It's kind of like air. You can't see the air, but you know you're breathing it, right? You know it's there. Interviewers love to ask about this, just to see if you freeze up at the word abstract. But if you just think of it as an invisible box that holds your variables and runs your code in two phases, you'll nail it every single time. Moving right along to Section 2, the power of closures. Remembering the past. Closures. They can honestly feel like a monster that breaks all the normal rules of programming. Here's the paradox. Normally, when a function finishes running, it dies. And when it dies, all the variables inside it are supposed to be completely destroyed and cleared from memory. So how on earth can an inner function remember and use variables from a parent function that has already finished running and vanished? Well, that brings us to the definition. A closure isn't just a function, it's an entire concept. It happens when a child function is returned from a parent function, and that child function continues to use the parent's variables. The inner function basically traps the parent's variables and absolutely refuses to let them go, even after the parent is long gone from the execution stack. So the really crucial part is how JavaScript pulls off this magic trick under the hood. When JavaScript reads your code and recognizes that a closure is happening, it quietly creates a special hidden backlink called the environment. It essentially saves a copy or a reference link to those parent variables. So when you run that returned child function way later on, it just follows the backlink to access the data it needs. It's pretty brilliant. So why is this such a massive deal? Because closures literally give you developer superpowers. They allow you to create private counters where every instance remembers its own independent tally. They give you encapsulation, meaning you can completely hide your inner logic and only expose exactly what you want the outside world to use. And most importantly, they prevent global variable pollution, stopping you from cluttering up your entire codebase with variables that could be accidentally ruined by other parts of your code. Section 3, Building Toaster Notifications, Putting Theory into Practice. Let's actually put this theory into practice and build something. If we break down the DOM manipulation required for a toaster notification, it's pretty straightforward. We set up our styling, we're using Tailwind CSS here. We create a parent container div in our HTML. Then, dynamically using JavaScript, we create a new child div for the actual notification, append it to the parent, and finally, we use a simple set timeout function to automatically remove that child after, say, 3 seconds. But here's where the absolute magic of closures kicks in and elevates the whole project. We use a parent function called createToaster. and pass in our base configurations, things like a dark theme, a 3-second duration, top right position. That parent function then returns the actual notification function. Because of closures, every single time you trigger a new toast, it perfectly remembers those private configurations without you ever having to define them again. The configs are safely locked away in the closure's memory. Section 4. Decoding the this keyword, the ultimate shapeshifter. All right, this brings us to the final and probably most notorious topic, the one thing that causes more interview panic than almost anything else. To understand the this keyword, you just have to accept one fundamental truth. Unlike normal variables, this has absolutely no fixed identity. It's the ultimate shapeshifter. Its value completely transforms based entirely on its immediate environment and how it's being called. Consider this your ultimate cheat sheet for the this keyword. Seriously, memorize these rules. If you console log this in the global scope, you get the window object. Inside a standard function, still the window object. But if you use it inside a standard ES5 method, which, remember, is just a function inside an object, this suddenly becomes the object itself. If you use it in an event handler, this becomes the specific HTML element you clicked on. And if you use it inside a class constructor, this represents a brand new blank object. But wait, hold on, there is a massive trap here that you absolutely need to be warned about. ES6 arrow functions do not have their own this value. They are basically thieves. They steal the this value from their parent's lexical scope. So if you try to be clever and use an arrow function for an object method, it skips the object entirely and pulls this from the parent's context, which is often the global window object. Suddenly, your code is broken and you have no idea why. Always use standard ES5 functions for object methods if you want this to refer to the object itself. So, we've navigated the invisible boxes of execution contexts, we've harnessed the memory-trapping superpowers of closures, we've built a real-world UI component, and we've finally tamed the shape-shifting this keyword. Now that you have these mental models firmly in place, it begs a much bigger question. If closures and the this keyword are just the foundational building blocks, what other incredible abstract secrets are hiding inside the modern JavaScript frameworks we blindly use every single day? Dive into your code editor, look under the hood, and find out.